Triangle congruence postulates. Now, we've been talking a lot about triangles. And what we've been in the past few objectives, what has happened is you've been told explicitly at the beginning, hey, the two triangles you're looking at are congruent. Fact. Now when we get to 92, and 92, as you can see, it's kind of long. We're going to do things backwards. You're going to look at two triangles, and we don't know if they're congruent or not. And just because they look close, we have to prove it. And that's what the triangle congruence postulates are for. Now, earlier in the year, we talked about what this word meant. Nobody in 4th hour could remember. We did have, you've heard segment addition postulate and angle addition postulate. Do anybody in here remember what the word postulate means? Anybody? I've heard it. Not a single person?
Cricket.
Sure you don't know? Galen, you know?
Of course he does. No, he doesn't.
I don't know. I don't even know if you can hear me back there.
No, he can't.
Do you know what postulate means? What is it?
Basically change.
Change? Yeah. Good guess though.
I know what I'm saying.
Okay. In geometry, the postulates are like the rules or the laws of geometry. So when something's called a postulate, it's just a fact and it's undisputed. It's like that is the way it is. So postulate means these are the rules, the laws. Like these are like the commandments of geometry.
What does that say? Rules/laws?
Rules or laws, however you want to think about it. If something's a postulate, it's going to be true in every case. So we can use it to our advantage. Now, triangle congruence postulates. The situation you're getting ready to see is you're going to look at two triangles, and we're going to have to use one of these laws to say yes or no, those are congruent triangles. So looking close enough is not good enough. You have to, like in a court of law, prove your case. So here we go. Sometimes you are going to be faced with two triangles that may appear to be congruent. However, in order to be certain, you must prove it. There are, well, the triangle congruence postulates are the key to proving triangle congruence. There's four main ones. I'm going to talk about the four main ones on this objective. There's also another one which we will use on 92 that is a special one. And that's the last one we're going to talk about. But there's four main ones and one special one. The special one is sometimes called a theorem instead of a postulate. Serves the same purpose though. All right, number one. This is going to be redundant. We're going to talk about one and then two and we'll come back. All right, the first one is called side, side, side. And sometimes we'll just shorten that up and say S, S, S. What it means is if you're looking at two triangles and you know that you've got three congruent sides in this one to this one. So you've got this one goes here, this one's congruent to this one, and this one's congruent to this one. Three sides in one are congruent to three sides in another. That triangle is congruent to the other triangle every single time. That's what the SSS postulate means. I got two triangles I'm looking at. I know three sides from this one are congruent to three sides from that one. So those triangles are congruent. If you look on the next page, this is what it's going to look like on your actual objective. And everybody does have an exercise right now over this objective. Nobody is ahead, nobody's further than this right now. Here's what it looks like. Which triangle congruence postulate or theorem can be used to prove ABC and CDB are congruent triangles? Now I put a side note over here. You got these two triangles right here. Notice that they are adjacent. That means that they're sharing a side. Anytime two triangles share a side, that side is obviously, they have that congruent in common. So we could put this right here. Now understand what we originally had is we kind of looked and said, okay, I know this one, these are congruent. So we had two congruent to two, but then we had a third one that was shared. So we really have three sides from this one are congruent to three sides from that one. So we would say that they are congruent by what postulate? What does it say?
SSS.
Side, side, side. You got three sides in this triangle, it's congruent to three sides in that triangle. So it's congruent by SSS, side, side, side. All right, here comes the second one. Side, angle, side. Also known as SAS or SAS. What this means is that you got two sides on one triangle congruent to two sides on another. And the angle that is between it, and that's important. The angle, if I got these two sides congruent to these two sides, and the angle between those two, congruent to the angle between those two, I got SAS. So it goes in order. I got side, angle, side, congruent to side, angle, side. Those are congruent by SAS. Now this is just like a footnote down here. ABC and EDF are congruent by SAS. Notice one thing though. The order that you write triangles congruent does matter. If I say ABC, then I've got to go, what goes with A? What angle? E. So if I say AB, I got to go EF. ABC, I got to say EFD. So if somebody said ABC is congruent to DEF, that is wrong. They said ABC is congruent to DEF. That is the wrong order. The order matters. A does not go with D. That person wrote it wrong. So that's just a side note. We kind of should know that from previous objective. All right, let's go and look at what SAS might look like on one of your example problems. Not always cut and dry. What triangle congruence postulate proves triangle GHL is congruent to KHJ? All right, what do we have right now? How many sides do we have in this triangle that are congruent to over there? How many?
3.
Sides.
2. Oh.
I got a 1 and a 1. I got a 2 and a 2. What I want you to notice, this little footnote over here to the left, says what? Keyword over here.
Vertical.
Vertical. Do you see some vertical angles in this picture?
Yeah.
That's what's not there. You should know, these are congruent. Those are vertical. Right there. Now you got enough to say, okay, I got two sides congruent to two sides and the angle between them. So I got SAS. SAS. So what congruence postulate proves these guys are congruent? SAS. SAS. It wasn't completely cut and dry because you had to realize that you're staring at some vertical angles. That's what gave it to you. Vertical angles are important to see, as well as shared sides. Okay, so that's 2. What was our first triangle congruence postulate?
Side, side, side.
SSS. Side, side, side. If you got 3 sides congruent to 3 sides, we're congruent. What's the second one?
SAS.
SAS. You got 2 sides and the angle between them, congruent to 2 sides and the angle between them, you got SAS.
Now we got AAS.
Now we got this next one, which is angle, angle, side. Also AAS, or sometimes you used to say A's. A's. What does it mean? This time you got 2 angles, congruent to 2 angles, and a side that is not between them. So, on this one, down here we've got angle, angle, side not between them. Congruent to angle, 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 side not between them. Now notice, if the side that we were talking about being congruent was AB, that would not work for A's. We can't have angle, angle, and side between them. It's got to be angle, angle, side not between. Down here at the bottom, let's look at this. This one is confusing. So this one's going to take some thought. All right, what proves DFM is congruent to NMF? All right, somebody tell me what those arrows mean that are in this picture.
Parallel.
Yes, those arrows mean parallel. Make sure you understand that that is it. It means parallel. It does not mean that DF and MN are congruent at all. Nobody's telling you that. All we're telling you is that these are parallel right here. And the reason that you need to know that is for this side note. What's the side note say?
They share the same side.
Okay, if the lines are parallel, we should be looking for, let me highlight it here for you.
Alternate two.
Yeah, you probably got some alternate interior angles. You need to look and see if you have some alternate interior angles congruent that we could mark. Now, alternate interior angles, often I like to think of it as they're in between a Z. Here's your parallel lines here and here. Your transversal is this one. So when you have this, like that, this is congruent to that. The Z made between them. So put the little marking, put a little double arc and a double arc. So now we can see that you actually have a second angle pair congruent. All right, now we got two angles from this triangle. You got angle, 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 angle. You got angle, angle. But we're trying to do A's. So there's got to be some side. Can you see it?
The one that they share.
The one they share. Do they share a side? Yes. That one's congruent. So if you want, you can put a tick mark on it and go, okay, there it is. So what do we really have? Angle, angle, shared side. Angle, angle, shared side. So you got A's. Okay, before we do the fourth one, let's go back to what we have. First one was what? SSS. You got three sides congruent to three sides. Triangles are congruent. What was the second one? SAS. You got SSS, then you got SAS. Meant two sides with an angle between them. Congruent to two sides with an angle between them. SSS, SAS. What was the third one? A's. AAS. You got two angles and the side that's not between them. This is the fourth one, and the last one until we get to that special one. All right, the fourth one is angle, side, angle. ASA, ASA. So you got side, side, side. You got SAS. You got A's. You got ASA. Obviously the A's, you got two angles and the side between them. So this time, we do want the side between them. That's what it looks like when you got angle, angle, side between. Congruent to angle, angle, side between. Those two triangles right there would be congruent, and we can prove it by ASA. Now let's look and see what this looks like. This one's pretty cut and dry. Only thing you need to notice is that we got two right angles. Any two right angles are congruent because all right angles are 90. So this is obviously congruent to that. So we have these two angles congruent to those two angles, and we got the side between them. So then this is congruent by what postulate? ASA. Two angles with the side between them. So it's ASA. What if, however, say that we didn't have these, say this wasn't here and this wasn't here. What if we had two angles and then we had, say we had PR and SU? What would we have if we had PR congruent to SU? Instead, that was our side.
Be side angle side. Wouldn't it?
Well, yeah, say we don't have this one. So we have this angle, and this side. This angle, and this side. Then what would we have? Angle, angle, side. So we'd have A's. So it doesn't matter. If you got two angles, that's great. It's one of the two. Is the side between them, or is the side not between them? That's what you have to ask yourself between, is it going to be ASA or AAS? All right, recap it all. The four main triangle postulates. We started with the first one, which was 3 sides, congruent to 3 sides. The second one,
SS.
you got 2 sides and an angle between them. Congruent to 2 sides and an angle between them. The third one, you got A's. You have 2 angles and the side is not between them. And the last one, you got 2 angles and the side between them. Those are the 4. Now, notice one combination. Austin, last hour, was obviously the first to notice the one combination of A's and S's that don't go together very well. And it was obviously this one, SSA. Now, one reason that helps to remember that this is not a good postulate. This is one that does not work. Is think about what that does if you wrote that backwards. Instead of SSA. I'm not going to write that because I'm video recording that. That's going to be on YouTube, so I'm going to put that. But just imagine what that spells if you put that backwards. And then remember, if you were trying to do an angle side-side, that spells something not so great. And that means that that's not a real postulate.
Yeah,
so don't
I was
use
just
it.
thinking about that whenever we were going through all this. I was like, how come there's not one of those?
Hey, you just put A with 2 stars.
Yeah, you put A with 2 stars.
I put A.
I'm going to put these 3 question
I put
marks.
AS and then stars.
All right, now, I'm going to say SSA most of the time.
Can I just spell it out?
You can spell it on your notes how you need to. But the thing is, remember, if it spells a bad word, it's because it's the one that's not a real postulate, so don't use it. Now, there is the special case that I talked about at the beginning. So SSA, or the other one, does not work unless the angle is a right angle. So like, in the SSA, there's 1A. If that 1A is a right angle, then we're going to go, okay, that actually will work. That's the one time that the SSA will work. We call it HL. Now, it's probably been a while since you've taught all the stuff about right triangles, but the only kind of triangle that has a hypotenuse is a right triangle. We're going to talk plenty about that in the next month, but it's called HL for hypotenuse and length. So we will use HL instead of SSA or the other one. Then it says down here, can you imagine why they chose a different name for this postulate? But remember, the one that goes angle side side does not work unless that A is a right angle. Then we'll go, hey, it does work. Special case, it's called HL. Last page here. Going in on this one right here. Let's look at what we got here. All right, how many sides do we have in this triangle that are congruent?
2.
2. And how many angles?
1, 2.
Yeah, well, we got 2 sides and 1 angle, right?
Yeah.
2 sides and 1 angle. S, S, A. S, S, A. What do we say about that?
HL. No?
Well, HL only if this is right, and that's not right.
So it'd be SAS.
Mhm.
Why can't it be like that?
All right, here's why it's not. This is a good question. Why is it not SAS? SAS is S-A-S. It's 2 S's, 2 sides. You'd have to have the angle between them. We got 2 sides, but we don't have the angle
So
between
not
them.
enough information.
It's not. What do we really have? Angle, side, side. Think what angle, side, side would abbreviate to, and that's not good. So what we got is, we can't tell. Maybe they are, maybe they aren't. We don't have enough information.
Whenever it's ever that answer, I was going to put on top of it ASX.
You can do that. You can do that. Put that on a quiz. I won't count on it. I'll go, well, she knows what she's talking about. Okay, now look at this one. If I tweak this problem, I try to make this look as close to the last one as possible, but I tweaked it just to where I changed that angle to be a little box there, which means these ones are now right. Now what do I still have? S, S, A. Yeah, I got A, S, and then another S. But what's my A this time? It's right. And so when we say, when you have SSA and it's right, special case, we're going to call it what?
HL.
HL. So in this case, these guys would be. This is the special case of the SSA. We call it HL. Now, like I said, everybody has this.
Wait, why are you recording?
He's videoing me. It's not even Facebook.
It's all about getting on. Okay, if you don't want to, go ahead and wave.
What are you talking about?
So yeah, I see Andreas back there. Okay. I couldn't record last time.